Hi, everybody. Welcome to another episode of the Extreme Performance Series video blogs. Today with me, I have one of our vMotion engineers that we've worked with and you've probably seen before, Sri.
Yeah, thanks, Mark. Yeah, I've been working on vMotion performance for last several years. And today we'll be focusing on vGPU vMotion, mainly because GPUs are becoming extremely popular in the data centers. And that's the reason we want to start focusing on vGPU vMotion.
Well, that's awesome because I agree with you. Certainly with the whole ML AI world, GPUs are definitely becoming a lot more prevalent. And so we've put a lot of work into optimizing now vMotion with GPUs attached to workloads, correct?
Exactly, yeah. So we'll just quickly talk about the basics of vGPU and vGPU vMotion, mainly to bring everybody on the same page. And then we'll talk about what are the main challenges with vGPU vMotion. We'll talk about those challenges and we'll talk about what optimizations we added to 8.0U2 to address all these challenges. Okay, we'll share some performance data as well as a short demo to show you how the user experience will look like in the 8.0U2. As again, we talked about, GPUs are becoming very prevalent in all the data centers. And in our test beds, we were using NVIDIA A40 GPU. And what I want to tell you here is the Grid vGPU Manager, if you're not familiar with it, is a software which is running inside the hypervisor, which is responsible for virtualizing the GPU. Okay, and it virtualizes this GPU and presents the GPU in the units of what we call as vGPU, which is virtualized GPU to all these VMs. So that way you can have multiple VMs which are configured with vGPU to have a simultaneous and direct access to one single physical GPU. Okay, what more? vGPU VM has not only performance similar to a bare metal performance, it also comes with all the virtualization benefits like vMotion, suspend and resume, and so on. So great performance and all the virtualization benefits. That's what we get with vGPU VM. And why is vGPU vMotion, challenging compared to regular vMotion? The main difference here is with VM memory, hypervisor has full visibility into how the guest is modifying the memory pages. But with vGPU memory, in contrast, hypervisor has no visibility into how the guest is modifying the vGPU memory, because this vGPU memory is all owned by the NVIDIA plugin. And so there's no way for us to track these guest page modifications, which is why it poses a significant challenge for us. That's the reason we had to transfer a significant portion of this vGPU memory when the VM is not actually running. As you may be aware, vMotion is done in a pre-cop iterative fashion, right? Only towards the end of the vMotion is when we stop the guest execution on the source host, take the checkpoint state, transfer this checkpoint state to the destination host, and then resume the VM from this checkpoint state. Now, for vGPU vMotion, as a part of the checkpoint state, we also transfer vGPU memory. And if the vGPU memory is small, it's not a problem, right? We can transfer it fast. But for a more common case like a 4GB, we see about 4 seconds of stun time. But as the vGPU VMs are getting larger and as the profiles are getting larger, let's say, with a 80GB profile, it can result in as much as 80 seconds of stun time, which is completely unacceptable, which is why we needed high performance vGPU vMotion.
That's really interesting, Sri, because certainly we've optimized vMotion to generally do very large memory footprints, like you said, on the orders of hundreds of microseconds. Optimally, we've seen that change over the last couple of releases here. Yeah, so to see the effect of moving up into the seconds realm is certainly a challenge. Well, show us what you've done to help this.
So we've done actually two main optimizations, okay? Let's talk about the first optimization. vMotion actually uses two channels, a control channel and a data channel. Okay, control channel is not designed to be high performant because it only uses a single TCP API connection, and its use case is mainly to transfer small control messages and a small amount of device state like network state or SVGA and so on, which are usually less than 128 megabytes, which is very, very easy to transfer. Hence, it was not actually designed to be high performant. We also have a data channel. And this data channel primary use case is to transfer all the large portions of memory, like VM memory or the VM disk state. And these are like large amount of data. That's the reason we use a high-performance data channel, which is managed by the VM kernel, which is actually managed by the migrate module running inside the VM kernel context. And as you can see, this data channel is driven by a number of vMotion stream helpers. it also uses multiple TCP/IP connections. In general, one thing I want to keep in mind is that all the data that traverses both the control and data channels finally have to go over the same physical vMotion network. Okay, just keep that in mind. And the issue was with vGPU memory, we were using it all, we're transferring it over a single, TCP/IP connection control channel, okay, which was very inefficient. And the big optimization that we did was we no longer transfer it on control channel, but all this vGPU memory now will be transferred over a high performance data channel, which significantly boosts network usage. Okay, and there's one more optimization we've done. With all the investigation, what we found was during the vGPU memory transfer, we were doing lots of unnecessary CPU-driven copies between various entities like VMX process, the VM kernel, and VMIOP, and so on. And to explain you this, let's take a quick look at the data journey. Whenever we need to transfer the vGPU memory, first we have to do this DMA transfer from the GPU memory to the device buffer, which is all owned by the NVIDIA plugin. Okay, we have no visibility into what's happening here. And now NVIDIA does its own magic and again does one more explicit copy to the VM buffer, which is again managed by NVIDIA. And then after more processing, it copies it to the migrate buffer, which is now owned by vMotion. And since, as you all know, by default, vMotion does encrypted vMotion, which is why we have to do one more implicit copy to encrypt this data. And once the encryption is all done, we have to do one more copy to the socket buffer. All in all, it resulted in 5 copies, which was extremely inefficient. And the big change that we made with 8.0 was we eliminated many copies. Once again, if you look at the data journey, whenever we need to transfer the vGPU memory during the vMotion, we still have to do a DMA copy to the device buffer, which is still owned by the NVIDIA plugin. But now, instead of doing an explicit copy, what NVIDIA is doing is it hands off the ownership of this memory to the VM buffer. So you can see both of them still own the same copy. We're not making 2 copies as we did before. And after VM buffer does more processing, once again, it hands off this data to a memory to the migrate buffer. Once again, you can see these are all denoted, as shown by dotted line. We are eliminating the explicit copies here. And migrate buffer still has to do one copy to do encryption. And once it does the copy, it has to do one more copy to the socket buffer. All in all, we eliminated 2 copies. So now let's take a look at the performance numbers. Okay, first let's focus on the network usage. Okay, and the workload here is the Heaven graphics workload. And in the network usage, you can see when we're transferring the vGPU memory, we see almost 3x improvement in the network usage. This because, as I explained earlier, instead of using a inefficient control channel, we are now transferring all the vGPU memory over a high performance data channel, which is why we're seeing almost a huge improvement in network usage. This change, along with all other changes that we talked about, which is eliminating the unnecessary memory copies, we saw a huge boost in guest performance. You can see the downtime has dropped by a factor of 8x. Earlier we were in the range of 4 seconds, which was not quite desirable. And now we are able to bring down this downtime to under 0.5 seconds on 822.
That's an amazing improvement to see that not only we obviously use the bandwidth appropriately now, but in fact, we've had such a positive effect on the stun time. I hear you brought something for us today to show us an actual demo.
Yes. So yeah, numbers tell one story, right? But we also want to see how it actually translates to improvement in user experience. For that, I have a short demo we'll show you here. The demo, what we have is we have 2 test beds. One test bed is running 70U3, and the other test bed we're running vSphere 80U2. And both test beds have identical hardware and same identical GPU. And both test beds also have a single VM running a graphics workload, okay, which is a Heaven workload. And what we're going to do is we're going to do a demo of 2 vMotions, back-to-back vMotions of the same VM, which is running this graphics workload. And we want to understand the impact of vMotion on the graphics workload, okay? So let's start the demo here. And let's start the Heaven workload. And you can see the Heaven workload is running. And now the first vMotion has started on both the test bed. And in general, you can see the impact of vMotion on this graphics workload is pretty minimal. right? It plays very smoothly till we hit the switchover phase. And you can see on 7.0, workload is passed for 4 seconds, and which you don't see on 8.0 because we made tremendous improvements in migrating this vGPU memory very, very efficiently. And you can also see how the second vMotion has already started. And now the second vMotion is already complete on 8.0. Okay, and you don't even see any impact on workload. And once again, you see one more 4 seconds pause on the 7.0 U3. And if you look on the right side, the 30 seconds video that we're playing already finished 7 seconds before it was playing on 7.0 U3. So overall, as you can see, the user experience will be far superior on 8.0 U2.
That's amazing, Sri. Thank you very much for highlighting that for us, because I think, yeah, in today's data center, that is certainly going to be very common. We're going to see increased GPU use. People love the fact that vMotion, highly capable for maintenance, things like that. We'll certainly see that in use. And I think that just bodes well and kind of highlights the fact that, again, vSphere is that amazing solid platform for even all of these new workloads that people are developing in the GPU age.
Exactly. I mean, in summary, we see like almost 8x improvement, and we strongly recommend customers to upgrade to 8.0 U2 if you're using GPUs.
Appreciate you joining us today on the Extreme Performance series, and everybody look forward to seeing a new video out shortly. Cheers.